Hi, I'm Bob. Welcome back to 5 Minute Econometrics. We will revisit the linear probability model today. For a linear model, when the outcome variable y is a dummy variable, the expected value of y can be interpreted as the probability that y equals 1, or the probability of success. The linear probability model describes the probability of success as a linear function of x. The coefficients of the explanatory variables measure the probability change in the outcome variable as the explanatory variable increases by 1 unit, holding other factors constant. We can show that when the outcome variable is a dummy variable, the model must exhibit heteroskedasticity. Here we use the expected values definition. The expected value of y equals the outcome times the probability of that outcome. Then we use the formula for variance. The linear probability model exhibits heteroskedasticity. We have two solutions. One is to compute the heteroskedasticity robust standard error, and the test statistics will be valid. Another solution is to use the weighted least squares method to address heteroskedasticity. We assume that the heteroskedasticity function hx equals the OLS fitted value times 1 minus the OLS fitted value, which can be estimated with the data. The weight will be 1 divided by the square root of the estimated heteroskedasticity function, hx hat. All variables in the original linear probability model are multiplied by the weight to give the transformed model. We then apply the OLS method on the transformed model. The OLS estimates from the transformed model are the weighted least squares WLS estimates. Here are the 4 steps to estimate the linear probability model by the weighted least squares method. This model uses students' high school GPA, ACT, and whether at least one of the parents attended college to explain the probability of owning a computer. The outcome variable is a dummy variable, PC, which equals 1 if the student owns a computer and 0 otherwise. The data were collected in the 1990s. Only about 40% of the students owned a personal computer in the sample. We first estimate the linear probability model by OLS. Because the linear probability model must have heteroskedasticity, we use the robust option of the regress command to compute the robust standard errors, robust t-statistics, and f-statistic. We then estimate the model by the weighted least squares method. We follow the 4 steps mentioned above. The idea is to transform the original linear probability model so that the transformed model has a constant error variance. I list the estimates from the linear probability models using these 3 methods: usual OLS, WLS, and robust OLS. The high school GPA and the ACT scores do not have statistically significant effects. Only parents' education significantly affects their children's probability of owning a computer. The probability of PC ownership is about 22% higher if at least one parent attended college. The effect is statistically significant at the levels above 2%. The standard errors from WLS are slightly smaller than those from the usual OLS. The estimates and the statistics by the usual OLS, the robust OLS, and the WLS are very close. They lead to the same conclusion. In many applications, the usual OLS estimates are not far off, and they are acceptable in the statistical inference. However, it is better to report the usual OLS, the robust OLS, and the WLS estimates and statistics for the linear probability model. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.